All right, welcome back. Hope you guys enjoyed working together in your groups. And I hope you got page 111 done. I know that this is hard information, and it's hard because you can't ask questions of the teacher. But I hope you guys understood it. I think you take time to go back over it, take time to learn it and do it yourselves. I hope take the first part of the class before you did this. I hope you already checked the answers using the answer book, which I will provide to the teacher via a PowerPoint, and so you can check your answers and make sure you have it right. You should all be turning in your group 4 pieces of paper, and on those pieces of paper should be 2-color ink, and on those 2-color ink it should have what you did yourself and what you did as a group. And that information be turned into me, and I'll grade it for 2 grades. You'll get 2 grades. You'll get a homework grade and you'll get a quiz grade. And we'll see how this goes. And maybe this is the best way to teach math, so that you don't have to hear me in person and you don't have to see my face on TV on it. It's easier to see just my voice, and maybe that helps you. For some of you. For some of you, I'm sure you're half asleep now. Johan, wake up. Johan, did you get a haircut? Nah, oh, okay. All right, okay. Sorry, I just thought maybe you had gotten a haircut, as it looks a little shorter than the last time I saw you. But that's great. All right, well, let's go ahead and open in a word of prayer, and I will let you guys do that together. I hope you've done that, because it's important to pray. It's important to make sure that you got together and I did that. All right, so here we go. Geometry, lesson 3.2. So please get out your books, and this time go ahead and title it 3.2. Proving parallel lines. Now let's go back and let's review really quickly. What did we say parallel lines were? And Brandon, you should know this one. Brandon, you know, what is a parallel line? Parallel lines are what? 2 things. They never intersect and they're on the same plane. Good. So we know that. We also learned there are 4 ways to cut a parallel line. There's 4 ways to cut a parallel line. So we did 4 of those. What is one of those ways, Jake? The first one, corresponding. Good. And of course, what did we know about corresponding angles is that they are congruent. Good. And the second one is consecutive interior. All right, consecutive interior, that's a different one. Consecutive interior, and that is the middle 2, right? So 2 and 3, remember, and 6 and 7. So you add those together and they equal 180 degrees. The other 2 are alternate exterior, alternate interior. And what did we know about alternate exterior and alternate interior? We knew they added up, or they equaled each other. They were congruent, okay? So now, what we're going to do is we're going to start doing some proving. Now, there was one other theorem we gave you, and that was a theorem about perpendicular transversal. That perpendicular said this, that if they're parallel, the lines are parallel, then the 2 lines, if one of them was perpendicular, then the other was perpendicular, okay? So therefore, they're perpendicular, they're parallel, and so on and so forth, okay? So, here we go. Now, what is the converse? So let's go back. Remember, chapter 2, we learned what a converse statement was. Katie, what's a converse statement? It's a switch. It's a switch. So now remember, if we switch this, if we switch a statement, it's taking the first part of the statement, the hypothesis, and putting it in place of the conclusion. So here's the go, okay? Remember, if 2 lines are cut by corresponding angles and they're congruent, the corresponding angles are congruent, then the lines are parallel. Then they're parallel. Now remember, it's the converse of that other statement you learned yesterday. The other statement said is if they are parallel, then the corresponding angles are congruent. Isn't it interesting? You can write it one way and write it the other way, and they both mean the same thing. It doesn't change what they are. They both mean the same thing. So, here's the point. The corresponding angle postulate and its converse can be combined by doing what's called our biconditional statement. Our biconditional statement, and I'll take a long time with this, but it is important to know that it reads both ways. It says this, 2 lines cut by a transversal are parallel if and only if the corresponding angles are congruent. So, in other words, if the corresponding angles are congruent, then they're parallel. If they're parallel, then their corresponding angles are congruent. It goes both ways. Okay, so that's important to understand and remember. Now, so let's look at here. Find the value of x. making both lines A and B that they're parallel. So if they're parallel, what do we know about the lines? That the angles are going to be congruent. Now notice, what kind of angle, what angle is this one and this one? They are corresponding angles. So if we were to solve this problem, the way we would solve it is we'd set it up like this. 6x minus 8 equals 4x plus 17. Well, what do? Well, it's the first thing you do once you set your problem up looking like this. The next thing you will do is you will then do some addition and subtraction. Watch what you do. You want to combine like terms. You want to bring stuff from this side and put it over to here and this side over here. So we're going to move, and we're going to move all numbers that do not have an x value over to this side. So we are going to subtract, we're going to add 8. Add 8. Okay, so what we do to one side, we must do to the other. Now, we want to bring this x over here. We got to combine them. So minus 4x minus 4x. That cancels, that cancels. What you do to one side, you must do to the other. When you do that, what do you get? You get 6x minus 4x is 2x. That's canceled, that's canceled. 17 plus 8 is 25. So 2x equals 25. Now, so that's what you're left with, 2x minus 25. Show you there. Now, what do we do next? Jake, we got to get x by itself. How do we get x by itself? Divide by 2. Good, because remember, we're going to take this 2, multiply by the inverse, and that gives us 12.5. So x equals 12.5. Any questions? Any questions on how you do this? So once again, step 1, we're going to combine like terms, the x's and the numbers, and then we'll end up with x minus equals 12.5. All right, any questions on that? Has everybody got it? All right, that's one, number 1. Second one, now remember, we did corresponding. Remember, corresponding was parallel. If we have parallel, then they're congruent. If they're congruent, the corresponding angles are, then the lines are parallel. So, Grayson, let's review what is consecutive exterior. Consecutive exterior said what? So they said what? One thing they said was that if they were parallel, then what do we know about the exterior angles? 5 and 4. They were what? Congruent. So what would the converse of that statement be? So the initial statement was if they were parallel, then they would be congruent. So what's the converse of that statement, Ian? The converse would be, hey, exactly, just the opposite. The exterior angles are congruent if the lines, then the lines will be parallel. So it's just the opposite. It makes it worth its while. It's saying it two ways. You can say it both ways. So let's go with this. And you don't need all this in your notes. It'd be good to have it in your notes, but it's not going to kill you. I'll make copies of the PowerPoint you'll have in your hand. But so you have as much information so you can keep looking at this information, try to help you, okay? All right, so what we see is this. Converse of the alternate interior. Now, so Brady, I'm sitting on your desk. Thank you for letting me sit on your desk. Brady, what is the alternate interior angle theorem? Now, let's think about this. What is the alternate interior angle? So we said 2 and 7, and we said what? That if those lines were parallel, then what did we know about 2 and 7? That we knew that they were what? Congruent. Yes, good, congruent. You're going to use that word a lot in these things. So they're congruent. So what would the converse, okay, remember what is converse? It's switching, it's not negating, it's switching. So when we switch, that they're parallel, therefore they're congruent, the opposite of that would be, or the converse of that would be, that if they are alternate interior angles are congruent, then the lines are parallel. Does anybody have any questions on that? So once again, corresponding angles are congruent. They're parallel lines. Parallel lines means they're corresponding angles. Alternate exterior angles means lines are parallel. If they're parallel, alternate exterior angles are congruent. Alternate interior angles are congruent, parallel lines, alternate interior. So they notice how they go back and forth and they stay that way and they don't change. And it makes it so that you can understand the material as quickly as possible. So now, lastly, consecutive angles. Now this one's a little bit different because it doesn't go exactly like this, but it's close. It's close because it doesn't deal with congruency. It deals with what? Remember, what were 6 and 7? They added up to what? They added up to 180 degrees. Good, Brenton. They add up to 180 degrees. Now, Johan, I want you to answer this next question. So, if you remember, what did we say about consecutive interior? They add up to 180. But what had to be true about these two lines in order for them to add up to 180? That is correct. They had to be parallel. So if they're parallel, then these added up to 180. So question, what's the converse? If these add up to 180, Caleb, what kind of lines are they? Parallel. Yeah, good job, Caleb. So this is what you got. Okay, we've already done this. We know this. We have it written. You'll have a typed copy of it. So I don't want to take too long on it, but I do want you to understand it. It's a good way to reinforce what you learned, okay? And so what you'll see is it says consecutive interior angles are supplementary, and then we have parallel lines. Good. Last one. Now remember, the last theorem we learned was perpendicular transversal theorem. Now, this is a lot of information. I know you're tired. I know I'm tired. All right, everybody stand up. Okay, everybody stand up where you are. Stop. Don't write anymore. You still writing. Katie, stop writing, please. All right, everybody get a bow and arrow. Pretend like you're going to shoot a bow and arrow. Shoot it in the air one time. All right, good. Okay, flap your arms like this. Good. All right, everybody sit down quietly and put your head down. Relax. Johan, put your head down. You always ask for a nap, and now you won't take one. All right. Now, lastly, the last theorem, and then we're going to do some problems together. The last theorem, go ahead and look up. I know, it's been a long day. Oh man, it's awful. I don't even know what day it is for you guys. It's like Friday, Saturday, maybe. Oh no, it's Thursday. Sorry, it's Thursday. So it's Thursday. I think I'm on Friday, so it's all messed up. I'm a little out of sorts. So sorry that this is so confusing for you, but we're just messing everything up for you today. But what would the converse of the perpendicular transversal be? It's very simple. If the two lines are perpendicular, hey, then guess what? Then these two lines are parallel. All these theorems are just the opposite of the ones you learned yesterday. They are what we learned yesterday. They just mean that you can have that biconditional statement that can be put in the middle. All right? Are there any questions? Good, because I can't answer them anyway. All right, so let's go to the next thing. We'll do some problems, okay? So we want to prove the converse of the perpendicular transversal. Okay, so that becomes difficult, but if you look at it closely, you see this. You'll see that angle 1 and angle 2, 3, okay, so you see that, and you see A and B. Now, what are we going to try to prove? Now, remember, what are we trying to prove? Let's go back to our statement. What are we trying to prove? We know what? We know that they're perpendicular lines, okay? We know they're perpendicular. So the given is that they're perpendicular lines. Now, we have to review something in order to do this. What do we know about perpendicular lines? What you know about perpendicular lines, and this is important, is this, is that if they're perpendicular, then they will have a right angle. They will have a right angle. So that's something that is important. Why is that important? Because then you have an angle, top and bottom, which then allows you the privilege to use alternate interior, alternate exterior, corresponding, or consecutive, because you have angles that are congruent. So now watch carefully. What we're going to be proving is that they are parallel. So we're going to prove these lines are parallel. What makes them parallel? Well, if you have angles that are congruent or something of that nature. So we're going to go through this here carefully. So our given is that AT are perpendicular and BT is perpendicular. So remember, what is perpendicular? This is the symbol for perpendicular. It's upside down T. All right, okay, upside down T. And we're going to be proving that A and B are congruent. So here we go. So we're starting with this, the first statement, and let's do this together and walk through this. The first statement is always our given, right? And so what is our given? A perpendicular to t equals p is perpendicular to b is perpendicular to t. Here's why. Because it's given. Good. So you got that. No questions. Right. Perfect. Now, watch carefully. Angle 1 and angle 3 are what kind of angles? They're right. Why are they right angles? Because what do we know? What do we know about perpendicular lines? What we know about perpendicular lines is that they make up what? A right angle. So, our definition of a perpendicular line is valuable here. So, angle 1 and angle 3 are right angles. Why? Because of the definition of perpendicular. Good. Now, what's our next step? Now, think about this through. Remember, what are we trying to prove? Now, remember, we're trying to prove that these two lines are parallel. What do we know is parallel? We know that corresponding angles are congruent. If the corresponding angles, if 1 and 3 are congruent, then we have parallel lines. Now, let me ask you a question. How do we get them to be congruent? Now, 1 and 3 are right angles. Now, let me ask you a question. What do we know about something that is a right angle? We know this. We learned last chapter there's a theorem that says all right angles are congruent. So, 1 and 3 are right angles, so therefore 1 is congruent to 3. Why? All right angles are congruent. Now, here's my next question. So, if those are congruent, if those angles are congruent, then what kind of lines do we have? Because remember, 1 and 3 are what kind of angles? They're what kind of angles, class? Corresponding. Oh, good. So, line A and line B are going to be parallel, and now why? Because what kind of angles are 1 and 3? Katie, that is correct. Corresponding angle theorem. Good. Are there any questions about this property? So in other words is this. You have it's given, you have that they're perpendicular. You have angle 1 and angle 3 are right angles. And that's important because why? We know the definition of perpendicular lines is that they have a right angle. We know that 1 is congruent to 3 because of a theorem that we learned last chapter. All right angles are congruent. And then lastly, A is parallel to B. Why? Because of corresponding angles. All right, any questions? Any questions? Good. All right, so this is new. All right, and I don't want to spend a long time on it, but I think it makes sense. If you look at this closely, you'll see that line A and line B, they're parallel. Now let me ask you a question. Line A and line B, will they ever intersect? Yes or no? No, they won't. Good. Now look at line B and line C. Will they ever intersect? No. So they're never going to get close together. So let me ask you a question. If line A and line B don't ever get closer together, and B and C never get closer together, will line A and C ever get closer together? The answer is no. So therefore, if you have one set of parallel lines and another set of parallel lines, you have transitive parallel lines. That is kind of scary. Here's the theorem that they ask you to have just in case. If you have two parallel lines on the step to the same line, then they are parallel to each other. So listen, if A is parallel to B, B is parallel to C, then A is parallel to C. All right, and that is important just simply because it just adds to the way that you can use that transitive property. All right? All right, so we have we have about two more slides to do. Those 2 slides will be some examples, and then we'll be done, and you'll have time to work on your homework. And so hopefully we're getting there. It seems like you're keeping up. I'm trying to not talk too fast. I do talk fast. So if you have an issue with getting some notes or you're missing something, what can you do? 2 things you can do. 1, you can ask a friend. Don't ask a friend while I'm talking. Respect, Caleb, respect. And then the other thing is what? The other way you can get this information is what? Well, that is you can take your little phone or your computer at home, not your tablet, and you can YouTube it, and you can watch my YouTube video again. It'll be awesome. I mean, I know you miss me. I know you're missing me, so this is a great way you can remind yourself of who I am. All right, now, all right, we have 2 examples we're going to do. We're going to example 3. one example, it's a big example, and we're going to do this together real quick, okay? Says this: which lines can be proved to be parallel? From each of the statements, state the postulate of the theorem that justifies your answer, okay? So what we're going to be doing is we're going to be looking at a little drawing over here, and that drawing over here is we're going to try to figure out why these are parallel, if the lines are parallel, okay? So we're trying to figure out if these are going to be parallel. So look with me quickly. We look at angle 1 and angle 2. So starting with angle 1 and angle 2, we'll look at our drawing, and let's see what we have, okay? Now listen. Here's what we have, all right? We have 1 and 2. Where's 1? Here's 2. So now, somebody tell me what type of angle 1 and 2 are. Jake, please tell me what type of angle 1 and 2 are. They are what we would like to call alternate interior. Good. Alternate interior. So they're opposite the transversal, and they're alternate interior. So, question. If they're congruent, what do we know about line A and line B? They're parallel. Why? They're what kind of angles, class? Alternate interior. So we will say that they're parallel, and why? The answer is alternate interior postulate, or theorem. Does that make sense? Has everybody got it? Any questions? No, so alternate interior, they're interior angles. Okay, good. Now, 2 and 3. So let's look at 2. And let's look at 3. Now let's look quickly. What kind of lines are going to be across parallel with 2 and 3? C and D. Why? What kind of angle is 2? What kind of angle is 3? Katie, can you answer that for me? 2 and 3 are what kind of angles? They are alternate exterior. Good. Alternate exterior. So would those two lines be parallel, C and D? Yes or no? Yes, they would. Why? Alternate exterior angles. Good. Now, lastly, C. Angle 5 and angle 6. What kind of angles are they? So let's look. Do they talk about these two angles, or do they talk about these two angles? Good, you got it. It's A and B. They are what kind of angles? Consecutive interior. Good. All right, consecutive interior. So we're talking lines A and B are parallel because of consecutive interior. So does everybody identify what you're doing? Yes. Yes. Awesome. All right. So here's your homework for tonight. Now remember, when you do your homework tonight, you will do page 117, 1 through 18. That's what you do at night. Now listen, when you come into class on Friday, you will be working on page 117, and you're going to do 19 to 25, 28, 29, 33, 35. Now listen, you will do these together. You will do this by yourself. This will be in one color ink, and this will be in a different color ink. You will turn in your group together. You will turn in all your homework, and it will be in one packet. All of this will be there. If you do not do this, you get a 0. You will get a 0. Do not cheat. You need to do this on your own. You do this as a group. This is what you do in class. This is what you do at home. All right? Any questions, please feel free to email me. I will gladly get back to you. I'm sure I will do that as shortly as possible. Have a great day. Miss you all. I hope you don't miss me too much, but it's been a great trip so far. We look forward to seeing you soon. And so I'm going to turn this up just a tiny bit because I think you missed the homework. So once again, it is page 117, 1 through 18, one color ink. Page 117, 19, 25, 28, 29, 33, 35. That's what you'll do together. And you need to have, everybody has to write it. It can't be one person writing for the whole group. All together. You'll have new partners, new groups. That'll be assigned by the teacher that will come in on the next day. All right, have a great day. Good luck, farewell, and I hope you enjoy the rest of your day. Bye.